Hello Internet, in this video we are going to be working some more on DataCube. So this is a project that has gone on for a while, a really long while. And so kind of had to pivot a little bit on where this was going and how all of this was working. Originally the idea was an ASP.NET application that connected and hosted a serial port as a service. So you could just send data to send over the serial port, which would send it to an Arduino, which would do that. I don't know if you can really see it back there, but it is actually running with this code. So I had to make some changes. Part of the problem is Windows IoT Core does not do serial communication except in Universal Windows Platform apps, which is kind of a little bit weird. Usually I would have expected that to be the other way, where the Universal Windows Platform was more restricted than the general platform, but that isn't the case apparently. So I have rewritten things, and what's running behind me is actually a remote connection. So I have actually sent my application over my internal network over to a Raspberry Pi that is running Windows 10 IoT Core. And then that is connected up to an Arduino Micro, which is actually driving those lights. So we have videos on how the whole lighting thing works. I've kind of gone through that before, so that code's all the same. Don't need to go through that. But this is all new. And really, this part is just gross. It's designed to be gross because I really just wanted to get this working. And so one of the things we lost with switching to the Universal Windows Platform is you can't host an ASP.NET application in the Universal Windows Platform. That doesn't work. So what I'm kind of pivoted towards is we're going to host this in Azure, and we're going to use Azure Service Bus, which is a messaging queue that can send messages over the cloud. And so effectively we'll have a bunch of other services, like one for Twitter or whatever. Probably one for YouTube, because that's obviously the big one. And then they'll push messages into that queue. And then we're actually going to pull those messages off and read them and then display the lights based on that. And so that's actually probably a better solution. And the reason for that is because it actually gives us some buffering. And so since it's a pull-based service, our cube is actually going to pull information off of that queue instead of the information getting pushed onto it, which hopefully means we can't just overload it with data. I'm sure we can still figure out a way to do that, but ideally that won't be as easy anymore. So this is what we have. It's gross. I kind of already said that. But what it does is it literally just goes through and finds every serial port that is, or every serial device that's connected. There's only one. So that's what it pulls off. Probably not the best way to do this, but anyway. Then it starts off an async task that after it grabs it, finding all those devices is an async task. So when that's done, we actually go through each of them and attempt to connect to that. If that's successful, then we go through and actually set up our connection for our Arduino. And then we run a infinite loop in a task that literally just pulls off random colors and then writes them onto our disk or onto our serial port. And so the way this whole thing works, that cube works, is if you write 3 consecutive bytes, it actually uses that as the red, green, and blue color, and then just pulls that together and sends that down the RGB strip. So I have some colors hard-coded here, which I just kind of sourced from the original actual Windows Phone 8 and Windows Phone 7 color codes, because I kind of just like them. And this whole thing this whole setup kind of works a little bit better with vivid colors than random colors. So that's sort of how that's going. We've got some code to kind of pull out the random color from that list and then pull it into a new byte array, write that, and then store that, which will actually send it over the bus. So that's how that works. I don't know what this access violation is. I'm pretty sure that's because this code is gross. I haven't been able to track it down. I don't know what's causing it. So that's a thing, and that's why everything stopped there. But I'm not so concerned about that. What I'd like to do in this video is kind of take this code and clean it up a bit, and we're actually going to be moving this over into the reactive extensions. So the idea is this is going to be our observer in our reactive extensions. So the idea in reactive is you have observable streams, and then you have observers that watch those streams and react to them. So what we're going to do is we are going to have a reactive stream setup that's going to feed data off of our Azure serial bus. We're going to grab that, throw it into that reactive queue, and then we're going to observe that data coming off and actually write that over the serial port. So that's how that whole thing's going to work. So we need to take all of this, which is just in our main page, and actually create a class for this and encapsulate the whole thing like that. So that's what we're doing today. That was a long intro. Super long intro. But anyway, let's create a serial folder, I guess. Sure. And this is going to be our serial observer. So I've already pulled in both the reactive extensions for Universal Windows Platform and the Azure Service Bus, not serial bus, service bus. So both of those are already here, so we can actually use them. We're not going to touch the Azure stuff yet. We just don't need it, but we can work with reactive. So we need to make this a observer, and it's going to observe a color message view model. Sure, we'll call it that. That means we're going to need a view model folder for to store our view models. And let's just call that view models. Sure. Oh well. Let's do color message view model like so. And now that we have that, this should compile again. Oh, come on. Oh, it's not going to like that because I actually need to break Windows. Let's pull in a using so we actually have that, and then I also need to implement its interface methods. So we get an onCompleted, which is going to happen hopefully never, but that's going to be when our stream is complete. So if we start closing things off, that's the final thing. So there won't be any messages after that. If there's an error in processing, that exception is going to get bubbled up to the onError callback. And then every time a message gets pushed off of it, because reactive extensions are a push-based mechanism compared to link or something, which is going to pull things off of a queue. And so the difference there is if you have an array, link is going to pull each of those elements off and just kind of say, I want to take this one and then this one. Reactive says, here you go, have this one, and then this one, and then this one. So it just kind of flips that whole paradigm. So we really care about this on next more than anything, but we're going to kind of work with all of them. And we're also going to need all of the serial stuff that we had from our main page. So all of this needs to kind of come and live over here, which is going to be super gross. And I broke everything. Nice. So first off, I need to actually import some of these things because we don't have them. So I'm going to drop some of those in. There we go. And this is mostly just kind of cleanup work, kind of trying to get it all into some sort of pseudo nice place. We have all of that fun async stuff. That's all cool. We're actually going to be passing in the color as part of our message view model. So we're probably not actually going to need that in this case, but I'm going to keep it for now. And so what we really need to do here is this bit. We need to connect to a serial device. Actually, we need to do that bit. So what we're actually going to do is we are going to, given a serial device to connect to, we're going to establish a connection to it, and then we're going to set up all of the connections or all of the stuff so we can actually connect to it and start writing our data out to it. So this is really what I care about, all of this, and we're actually going to need to store that serial port somewhere, but oh well. So this is going to be a serial device. And we'll just call it the serial device because I guess that's all we need. And so I'm actually going to make this a private constructor for our serial observer. And the reason I'm making it private is because we're probably going to use a builder pattern for this, because I'm going to want this to be async because we have an async task. And you can't really await constructors. That's just weird. So we're going to need this, and I'm actually going to pass in the serial device. So this constructor is actually going to only be used internally, and it's just going to be used to set things up. It isn't going to be used to update other things. Let's mark this as read only, so we don't go and update that reference afterwards, because that just wouldn't be good. Mostly a safety thing. And that wasn't right. Cool. So we're saving our serial device from our constructor into this read-only variable, and everything is good there. So now all of that code I copied, we need to put that into a public static serial observer. And what do we want to call this? Like generate or build or connect. Public static async. It's going to be an async method, so you have to label it as async or it's not going to like that. Which means it has to return a task, otherwise you're not really following the async stuff. And then we need a string for the ID. And that's going to be whatever we're connecting to. Then I just copy and paste it. Grab the ID. And if our serial port is not null, we'll do all of that. And then return a new serial observer of our serial. So it's going to effectively connect this thing. And we can remove some of this stuff because I was trying to use I wasn't trying to use usings in that main page thing just to keep the cleanup to a minimum. It probably just made more work for me, but kind of learning as I go. But anyway, this should return a new serial observer if we found it or if we created it. Otherwise, we're going to throw a new in ID not found exception something. I don't know entirely what we'll throw. Do you throw anything? Not really. Okay then. That's less useful. Let's throw a null reference exception. That's not really what I want. We'll go with this for now and just say serial device with ID couldn't be found. And let's actually use some string interpolation here because that's just better. So we'll end up with, how do we do that? Like that, I think. Uh-oh. Uh-oh. Send help. Okay. This is getting out of hand. Right? I thought it was a $sign. Hold on. I want to go check this because I'm pretty sure I'm doing this right, and I may just be thinking of something wrong. But we want to use string interpolation for this because that's just the better way to do what I was trying to do. So I will be right back. All right, I found it. Turns out I was making it way more difficult than it needed to be. You just use curly brackets, just like you would if you're doing a string format, but you can actually put the variable name in instead of a number. Got it. Okay, so that should get us an error if we can't connect. Hopefully that's enough that we can actually tell what's going on. So this should set up everything. This is the information that I need to connect to the Arduino. We probably would want to move this somewhere else other than here. But for now, this is fine. So the next thing that we need is there is this data writer, which we're using to actually write out to our stream. We're going to want to import that. And so we actually need this. The colors are kind of in the way there, but that's all right. So we're going to grab all of this and remove everything else. And so what we're actually sending is this color information. So we're writing 3 bytes because RGB. And so we need to send the red, green, and blue values, which we're not getting yet. But we should be able to pull those off of this value. So let's grab our serial device, like so. And I think this is a stream. Yeah, it's disposable. So let's do a using around this instead. That should make everything just better. So this should be automatically disposed of, this data writer. So we shouldn't need to worry too much about that. This is going to need to be async, which I don't entirely know how that messes with reactive, but we're going to find out. And so the final bit, the final thing that we need is to actually read those colors off. And so we're just going to take our, we'll call it the message. And we're just going to grab the message dot, I guess this is the part where we figure out what our message is. So what's going to happen, the eventual stream bit that's going to happen is we're going to read information off of this service bus. We're going to transform that information into these view models. It probably won't be the same that's actually on the bus. And then after that, we're going to actually use that. So really all I need to save here is going to be a public color. And I don't think I can call that just the color, but we're going to try. It's really not going to like that. So let's call this RGB. No, I don't. I really don't like that. Well, actually, that could work. Because then I can do public byte R get. This is really gross, but we're going to get, which is going to return the RGB.R. So think swizzle operators, which I don't think we'll need, and we probably don't, but you know, why not? Red, green, and blue, because red, green, and blue. And so we need a color, which we can just put in our view models. I guess that works. Actually, we can put it right here. Public color, or public color like that. And so this is actually going to store a red or a byte for the red, which is going to have a public get and a private set. And we'll do that for all three of these. So there's a red, a green, and a blue. And so that is our color. Then, with each of these, we actually need a constructor too. So let's do the color. Bytes, red, green, and blue. And so R equals R, G equals G, B equals B. We're actually going to want to add a this, which isn't strictly required. We don't actually need to do this. The reason I'm doing it is because this is confusing otherwise, because you're setting R to R and that it just, I don't know, I don't like it. So that should kind of hopefully prevent any weird errors, but there's our color. Here's how we'd get it. And so we can either grab it, the RGB, and then pull each value off individually, or we can actually just access each of them individually, just doing RG and B. So let's go back to our serial observer, and we're just going to do message.r, message.g, and message.b. And that's that. That's all we need. We don't need onCompleted or onException. I'm going to actually make it so those will still throw exceptions, because right now we don't need to worry about those. But that, hopefully, is everything we need here. So I'm actually going to delete everything else. That was a lie. I'm not going to delete everything else. Instead, we're going to go back to our main page, and I'm going to recreate everything. And so instead of doing all of this, I'm going to create an observer or an observable stream that can actually handle this instead of doing whatever we're doing here. So all of this can come out. And all we're doing now is finding these devices and connecting to them. So we need to create our observer, serial observer dot that. Let's connect to that with our device.id. It is very unhappy with what I'm doing here. I got rid of all of those references. We'll add them back for now, mostly just because that's the easy way to solve that. And then we can, oops, not do that. There we go. So now we grab our serial device, connect to it, and connect to this device.id. And so we actually probably want to, let's rename this to connect async, because it's an async call. So just C# standard says any async call should end in async, just so you know as a programmer that it's an async call without having to look at the return type or anything like that. So let's grab a serial observer out of that. We can actually just use a var and store it in our observer. Cool. So we get our observer out of this connect async, but we don't have an observable stream yet. So let's do observable. Now, I have not actually done this in C#, so one moment. I think I may need to, it just may not be listing it. There we go. Interval, yeah. So if we do an interval of a time span, dot, what do we want? From seconds, so let's just do every second. So what this is going to do is it's going to actually send a message down every tick, and that tick is defined by the interval. So this is an observable that will continue to send messages over and over again until forever. So, one moment. Awesome. Okay. Okay, that was less important. Got some other things that I need to just kind of keep an eye on. So anyway, let's go back to this. We have the observable interval. We're going to take that and actually send a message down. And let's actually map that message. It's not a map here. It is a select. So we're going to select this I. Doesn't particularly matter. But what we're going to do is create a new color message view model. And that does not have anything, so let's do a new RGB with a new color. And so this new color is going to actually, I think we can do something fun with this. So let's do, how would we make this interesting? Let's do I times 2 plus 128, which will be half of a byte. And then we are going to mod that by 255, and I want that as a byte. So that is one gross way to pull out a color. We can kind of format this in a slightly nicer way. So we're taking a color message with the RGB equal to a new color where the byte is going to start. So red is going to start at half brightness. And then we're also going to add in a purple color. So to do that, red, green, and blue. So no green, but then we need blue. And so we can actually offset that by just removing this plus 128. And so the idea here, assuming I did all of this correctly, is that this is actually going to kind of start red and then kind of shift into purple, and then it will drop and then kind of go back, I guess. I guess we'll figure it out. But that's that. So, color does not contain a constructor that takes that many arguments. Takes 3. Oh, ha. Got it. Cool. So there's our color. Why does it think I'm close? Oh, because I am. Okay. So we need to add another bracket there. Kind of in parentheses hell right now, but we're going to work through that. And so red, green, blue. We have red, we have no green in this, and we have some blue. We could add some green actually if we wanted to. Nah, it's fine. So then this multiplication just kind of affects how fast it will actually change. So this is actually going to change fairly slowly just because we're only doing times 2. So it's actually going to take it about 2 minutes to go through a full cycle. And so I don't know if that's good or bad. We'll find out. But really all we're trying to do here is actually send data down our pipe. So here is the finished Oh, because it's not awaited, all of that is fun? Okay. You can wait. Okay, that's interesting. Oh, okay. Anyway, Sorry, getting distracted, but we can take this observable now. iObservable of our, we don't actually need to store it like that. I should move my mouse. So this is going to be our color message queue. And so after we have our color message queue, let's subscribe to that. So let's subscribe our observer. There it is. Cool. And so now our observer is going to actually watch that, and hopefully, assuming all of that is working, we should actually kind of see a color progression happen behind me. So let's see what happens. If I deploy this, I actually have it set to deploy to my remote machine, so this is actually going to connect directly to my Raspberry Pi behind me. So it should just go. One of the cool things, Visual Studio actually automatically detects these IoT devices on your network. So for me, it actually knows that I have a Raspberry Pi back there that I can deploy to, and it can actually connect to any other Windows machine on my network. So I can like deploy to my laptop if I feel like that. So that's interesting, but anyway, we should see it go, and it looks like it's definitely red, which I guess is something that we're kind of hoping for. And then it died. Why did it die? I don't know. It definitely was there definitely was red. I know that, but I don't know why anything else. I was kind of hoping this would have fixed the like out of memory, or not the access violation exception, because there we got 1, but now everything's broke. It's always the same. So something's causing it to get very annoyed with me. And I'm not entirely sure what. It wasn't really on my radar to fix that particular issue. But I can take a look quick and we'll see if we figure it out. But this was sort of where I wanted to get with this video, is kind of get to the point where we have an observable thing that we can kind of connect to, and our code actually looks somewhat clean. It's not perfect still, but it's way better than it was. So let's see if we can fix or figure out what's causing this. I'm not sure we're going to have enough information debugging over ARM, or debugging remotely like this. I don't think we're getting enough information from that. And I may just need to like restart it or update it or something. So let's see. We're getting a exit code is minus a lot, so something very evil. Let's see. I don't even know where to start for this. What if I change this to 64-bit and run this locally? I mean, obviously it's not going to work because I don't have that connected to this computer, but I'm curious if we'll still see that error or not. So this is our wonderful application. Not configured to debug this unhandled exception. Detach the current debugger. I don't know what's going on. I don't know, let's find out. This is at least more than we were getting. I don't know if this is going to be any help. Everything unable to attach. The current debugger is already attached. Well, yes. Correct. You're definitely correct. Those are definitely my speakers. Cool. I'm going to look into this on my own time, I think. I don't think it's worth it for you guys to watch me poke at this, because I don't really know what I'm doing. And this is probably going to take me a decent chunk of time. So I will leave it here. And next video, we're actually going to start working on that service bus stuff. So all of these colors are then going to be sourced from the cloud. And then hopefully we can actually start writing services to actually throw messages on there. So hopefully, like when you're, I don't know, chatting during a live stream, for example, not only does your message show up in chat, but it actually like gets visually represented back there. At least that's the idea. And then there'll also be like when people view videos on YouTube and things like that. I haven't really figured out entirely what we're gonna do, but we can do whatever. It's just lights. So yeah, I don't know. But that's it for this video. So if there's anything else you guys want to see, any suggestions you have for me, let me know in the comments below and I will definitely take a look. Otherwise, maybe consider joining our Discord channel. There's a link in the description for that. We kind of talk about development, and people have some really cool projects that they share there. So if you guys want to become a part of that, definitely consider it. But that's it for this video. So till next time, see you, Internet.